So today we are going to factor quadratics of the form that are standard form, just like this. And sometimes there will be a number in the front. Sometimes the number will be 1. So we'll just run through it. So let's see. First, I want to show you the long, complicated, disgusting way. If you like this way and you want to keep doing this, that's word to your grandmother's aunt. But if you don't like the tediousness of this, then that's where this method, Snowflake, which I think is one of the most elegant ways to solve any math problem I've ever seen in the history of my experience with math. So let's show you the long, disgusting way, and then we'll show you a more elegant way to do it. Okay, so remember what factoring means. There you go. Good. So when you are factoring, essentially, you're making it into a multiplication problem. So something times something. So in the same way, if you're factoring this, your answer is going to look like x plus whatever and times x plus whatever. Okay? So it's going to look like this, a product of two terms, or two polynomials, we call them. All right, so ultimately, since we're asked to factor, and there's a misprint here, we want to write this in factored form. How do I write it so it looks more like parentheses, x plus something, and then x plus something else? Like that. So how do we write it to be in factored form? And one way is just to guess. You can start guessing. The upside of that is guessing. If you guess right, it's very fast. The downside is guessing right the first time is pretty slim. So let's walk through a tedious method called grouping, which is probably one of the official ways to do it. Some people have also called this the explosion method or the bomb method or something like that, because what we're doing is taking a number and splitting it up. We're exploding it. So let's see here. Let's walk through all these ugly steps. Number 1, what we're going to do is factor out any GCF if there is in all the terms. And the GCF of these 3 terms is just 1. And notice that there's no negative in the front. So that's why it says leading negative if needed. So this is just a check. There's nothing done here. Now here is the super secret key. We have to find the factors of AC that sum to B. Now what does AC mean? A is take your A times your C and multiply them together. So let's see here. What's the A here? A is 1, it's that number there. And C is 20, right there. So what we have to do is multiply these two numbers together. Notice I'm including the positive and the negatives if they are. And I want to factor them. And what's the key on this? So I just take my 20. And I'm going to find all the factors of them. And one of the factors pair is going to add up to the B. I want it to add to this 9. Okay, so let's just run through and see what these factors are. 20 times 1. That adds up to 21, so that's not the one I want. What's another pair of factors besides 20 and 1? Anybody? 10 and 2. But those add up to 12. Doesn't work. Anybody else? What's another one? 5 and 4. What do those add up to? There we go. So here are the factors that I want. 5 and 4. 5 and 4. So what do I do with that? So notice over here what it says. I'm going to substitute B with those two factors. Instead of writing a 9, I'm going to write 5 plus 4. So this is what it looks like here. So instead of writing 9x, I'm going to split it up to be a 5x plus a 4x. Now notice everything else is going to come down. The x squared comes down the same, and the 20 comes down the same. So some people, at least in this school, have called it the bomb method, explosion method, because you take the B term and you explode it out to some factors. All right, what's the next part say? Group each half. Group each half. So what does that look like? all I do is put parentheses around each half like this. That's the group each half part. Next step says I'm going to factor each half. So I'm going to pull out anything common in the two. So what's common between these two? I can pull out an x. So I do. Let me pull out an x from the first half. What about in the second half? What can I pull out over here? Oh, it's a 4. I can pull out a 4. If I take that x plus 5 and this x plus 5, both of those can be factored out. And what's remaining? The x plus 4 is inside the parentheses. So a little bit tedious. Now, of course, we can do a quick check here. If I did a quick check, x times x is x squared. 5 times x is 5x. 4 times x is 4x. And 5 times 4 is 20. So x squared plus 9x plus 20. So now that I've utterly confused you, let's try to make it as easy as possible. So I love this method. It's called the Snowflake Method because essentially what you do is you make an x and then you put one additional horizontal line through it. So notice it now gives me 6 places to fill in. So here's what we're going to do. We're still going to do what we did up here where we found the factors of a times c. That is, in this case, 1 times 20. And we kept looking until we found the factors that added to 9. So we're going to find the factors of AC that sum to B. So notice where we're going to put that. A times C just goes in the top here. So 20 times 1 is just 20. So we put 20 in the top. B is going to go on the bottom. B goes on the bottom. So in this case, B is positive 9. So I place positive 9 down there. And always on the left and right, so here and here, what you do is just take whatever, essentially whatever's right there, except for the square. So I see a 1x. So I'm just going to put a 1x right there. If it were a 2 in the front, the leading coefficient, I would put 2x, etc. Now, we ask ourselves, what are the factors of 20 that add to 9? Now, we already know that answer. The answer is 4 and 5. So, I'm going to put both 4 and 5 in there. And it never matters where you put the 4 or the 5. As long as you put the 4 or the 5 here and the 4 or the 5 here. Now, notice what we see. Do you see this wing right here? 1x and a 4, and this wing over here, the 1x and the 5, there is your actual answer, and you're done. There is no more crazy work to do. The answer is simply x plus 4, that's what's on the left side, and x plus 5. Notice I'm dropping the 1, I don't need that 1 when I write it down. And that's it. X plus 4 is here, and x plus 5 is here. And you're done. So let's now look at the next part here. Instantly I see this situation. So let's go ahead and set up the snowflake, draw an X, and then draw a horizontal line. A times C, notice I'm keeping track of the positives and the negatives in there. So I place the 42 up on the top. And we'll take positive 13, and that goes on the bottom. B goes on the bottom. A times C on the top, B goes on the bottom. And now just to complete it, here I'm going to put the 1x here and the 1x here. And now we think to ourselves, and we can write it out too, but we say what two numbers multiply to 42 add to 13? So they multiply this direction and they sum this direction. So what are the factors of 42 that sum to 13? And you could say, well, let's say 42 and 1. That doesn't work. What else? Anybody see offhand real quick what it is? 7 and 6. 7 works here and 6 works there. And notice my wings right here, x plus 7. And on the left side, x plus 6. And now I'm in factored form. So let's zip through this one. I set this one up. I'm going to put a 21 in the top, negative 10 on the bottom. 1x is going to flank there. And I ask myself, what two numbers multiply to a positive but add to a negative? So they both have to be negative. And 3, 7. There we go. So x minus 3 and x minus 7. Again, I'm dropping that 1. I do not need it. And here we go. Fairly quick. Next page. So here we're going to find the factors of negative 5 that sum to positive 4. And those would be negative 1 and positive 5. So there we go, x minus 1 and x plus 5. There we go. Now this one over here, if you remember what the very first step was, the very first step was to factor out anything that's a GCF, including a leading negative, if there is a negative in the front. So I'm actually going to factor out the negative to begin with, which means I get negative 12w and positive 35. So I'm going to factor out the leading negative. Now ignoring the negative, and I'll just bring that down at the very end, let's go ahead and set this one up. Again, I'm now using the interior right here. I'm not using the original problem. I'm using the inside parentheses. So positive 35 there, negative 12 there, 1w, 1w. If you want to just write w and ignore the 1 in these contexts, that's fine. So what two numbers multiply to a negative, a positive, but add to a negative? They both have to be negative. And 5, 7. Negative 5 plus negative 7 is negative 12. So I'm going to bring down this negative. So I have the negative out there. And then w minus 5 and w minus 7. Now, let's show you when sometimes a is not 1. And so here's a not being 1. So the first thing, according to the instructions, is there a common factor to pull out? And the answer is no. So what I'm going to do is go ahead and set up my snowflake. But what do I put on top? 2 times 12. So I'm going to put 24 on the top of this. I'm going to put the b on the bottom, so that's positive 11. And on the flank here, I'm going to put the 2x and 2x. Now I ask myself the question, what two numbers multiply to 24 and add to 11? So let me just try a few, because it might take a few steps. So clearly 24 and 1, those add to 25, so that's not it. 12 and 2, oh, that adds to 14, that's too big. So what about 8 and 3? Oh, good, that works. So notice it took me a few times to try it, and that's the expectation, is that you will try it more than once. Don't just stare and hope that, the angels are going to bless you with the knowledge. Go ahead and keep trying all the factors. And if none of them work, then that's your answer. Can't be factored. That would be your final result. So now here's the situation. I'm going to clean it up just a little bit so you can see some things here. The 8 and the 3 could have been switched. Now notice here, instead of just saying, here are my answers, what I'm going to do is pretend they are fractions, and you simplify the fraction. Watch. What can I reduce from both of these right here? I can divide by 2. So go ahead and do that. Divide by 2 to get x over 4. And what about this one? Is there anything that I can reduce? And the answer is no. 2 and 3, there's no common factors. So the 2x plus 3 is one of my factors. And the reduced fraction over here acts as the other factor. So pay attention is that you almost always have to reduce one of the fractions. Sometimes it'll be both, but one of these wings here will probably reduce, especially when there is an A in the front, especially when there's an A in the front.